Hi everyone, this is Smriti. Welcome to QA automation classes. So we have completed all the sessions from the functional programming, including the streams, and I'm going to start the question answer sessions. And these are the real-time interview questions which you can expect during your interviews from the functional programming side. So please pay attention and try to understand the concepts as much as possible. If you have any questions or doubt, please feel free to put them in the comment section. I'll get back to you as soon as possible. Okay, so let's start. So the first question, what exactly is a functional interface? Okay, and can a functional interface extend or inherit another interface? Okay, so we know the functional interface is an interface which can have only single abstract method, SAM, single abstract method. Okay, so and if it extends another interface, then the parent interface method will also be part of the functional interface, right? So when interface extends another interface, the parent interface, whatever methods are declared over there, that also will become as the content of the current interface or the child interface. Okay, so which is against the basic design principle of the functional interface, because we are saying the functional interface should have only one single abstract method. Okay, so in order to support that, let's try to see that in action. I'll do one thing, create a package. So let's create a new Java class. Let's say interface. Okay, I'll say I'm going to create example one, or say parent. So parent interface. So let's say we have a interface that is called as the parent, and it has a method called as the show. Okay, and now I'm going to create another interface which will be extending this parent, and then we'll try to add a new method to that declaration, only declaration. So let's say new Java class. I'll say child. It's not exactly class, we're going to add the interface. Okay, so now child, public interface child. I'll say this child is going to extend the parent, extends uh, parents, right? Parent extends parent. And okay, cool. Display. Okay, so now if you see, we don't have any problem till now. Why? Because we have one interface called as the parent, and then sorry, we have one interface called as the parent, and it has one method declared. Similarly, we have another interface called the child, and it has one method declared. Both are abstract methods has been declared. But let's say I want to make this child as the functional interface. How to make a child as the functional interface? So if it has only one abstract method, then it will be functional interface, or we can mark that with the @ annotation, right? So @ let's say functional interface. As soon as I select this one, right, you can see a error here or warning here. So why? It's saying multiple non-overriding abstract methods found in interface interview.child. Okay, the interview is the package, and in the child interface we are seeing multiple non-overriding abstract methods. So here, if you see here, it has one method display. Even from the parent, it has its own method called as the show. So the child has two abstract methods, right? And these two abstract method is not possible, because that is the basic principle of the functional programming. We should have a single abstract method, SAM. We say that SAM, that is a single abstract method. Okay, so here we are violating that principle. We are not going to have the single abstract method. Here we are going to have the multiple abstract method, that is called as SA and M, single abstract method. Okay, so now if you see, that is not possible. we are getting the errors over here. Okay, so what we can do, we can get rid of the this extend keyword, then it should work. So now see, this is the interface child and it has only one single abstract method, so it is a functional interface, so it will work now. So first question is clear, guys. We cannot extend or inherit another interface which also has the abstract methods. Okay, so this is the first question. Hope everyone is fine. And let's see what are the content of the functional interfaces. So we saw what is the functional interface, and now what can be the content of the functional interface. So functional interface, as I told you, it will have single abstract method. Along with it, it can have one or multiple default, static, and overridden methods. Okay, we can have multiple default methods or non-default method. Here, if you see in the interface child, we didn't have any other methods, only single abstract method we had. We didn't have any default, any static or overridden methods. Okay, so and uh, and you have seen we can use this annotation at the functional interface, right, to specify that it is a functional interface. Okay, this is optional. Okay, it is not mandatory. If you want to specify, you can specify, and it is always a better practice to specify at the functional interface annotation, because maybe someone else who's going through your code or who is working on your same set of the code, they will see, okay, there is an interface and I can use it interface, and I can really use this one, and I can add few of my own methods over there, right? If it is marked or annotated with at the functional interface, then the other developers will think, okay, so this is only that single abstract method is declared and it is being used in somewhere in the other application, right? So this is a functional interface and I'm not going to add any more method to it. Okay, so that's how the functional interface annotation can be used. It's optional. Okay, so and if we have multiple single abstract methods, definitely we'll get the warning message, compilation error also, right? So okay, so let's see what is the use of the default method in the functional interface. Okay, so as I have told you, a functional interface can have the one or more default methods, and what exactly is this default method, right? This default method was introduced in Java 8, that is in the functional programming, and it has a function body. So in interface, usually we declare the function. We don't have the method body, right? The definition part we didn't have there. But in the default functional interface, we can have in the default method we can have the functional body also, right? And the implementing class, okay, which is going to implement this interface, they can either override the default method, okay, and okay, so you cannot have a default method only inside the functional interface, or at least we need to give the single abstract method. Okay, so single abstract method inside a functional interface is mandatory. If you want to say, okay, I'll just define the single default method, so that cannot be called as a functional interface. Okay, so we'll see an example to support our statement whatever we told. So how the default interface can be added, sorry, how the default method can be added to the functional interface. So let's see, let's create a new interface here. Do we have an interface over here? No, right? Okay, let's with the Java class, let's say default. Okay, so let's say default method. Okay, so, sorry, I made it class. Let me delete this one. I'll make it one more time. So let's see, new Java class, select interface, let's say default method, default method. Okay, so public interface default method, and we are going to say at the functional interface. That is what we are going to define, functional interface. Okay, annotated with the functional interface. Why error? Because we have not defined any method here, single abstract method we have to define. So first thing is, I told we can define a default method inside it. Okay, so let's define a default method. So let's say public void. Okay, and default method will always have the keyword default. Okay, so let's say public default, and return type of the method is void, and I'll say just a show method or display method. Okay, show. Okay, so this is the method we are going to define, and we have to provide the body here. So let's say s out, I'll say hello world. Okay, so this is the default method that I'm defining here, but still it is going to give you a error. Why it is giving you error? Because we have to at least define one abstract method. Okay, we always say the functional programming means it is SAM. SAM means single abstract method. Single abstract method, it should be present mandatorily. If this is not present, it's not going to be considered as a functional interface. So in order to have a single abstract method, we can define one method. So now define, we have to declare public, let's say void area, and done. See, now the error is also gone. So this become a functional interface having one default method, okay, and one abstract ASM, right? Yeah. So now this is the example of the default method, right? Yeah, cool. So if you guys have any doubt, please feel free to put them in the comment section. I'll be getting them to the as soon as possible. Okay. So we are done with the default method, and let's see the third question. The lambda expression in Java. Okay. So what exactly is the lambda expression, right? And how it is with respect to the functional interface, how it is going to be used. Okay, so the lambda expression, as you know, is an anonymous function, right? Without any name, it doesn't have any name. Whenever we design the lambda, we don't usually give any name, and there are also not any type information for the argument and return type. So if you see, I'm not saying int a comma int b inside the parenthesis for one particular function, because I know what parameter during the runtime it is going to get decided. Depending upon the value provided, it is going to determine what type of the value is provided to me, whether it is an integer type or a float type or a string type, right, or a character type or a boolean type. It is going to uh, infer that information, right? So similarly, return type also, it is after the computation, it is going to infer that one by its own. So that's why that is called as a type inference. Okay, automatically it determines the type. Okay, so in lambda we do not have any return type or any type information for the arguments and return type. Okay, so lambda can only be applied to the single abstract method of the functional interface. Okay, that is the most important concept. It can only be applied to the single abstract method of the functional interfaces. So let's see one example. So let's create Java class. I'll say I'm going to create an interface. I'll say area something. Okay, so area interface. Okay, so let's say this is the area interface. I'll mark that with the functional interface. Okay, and I have to define a single abstract method. So let's define single abstract method. I'll say public int, it's going to return integer. So I'll say area, and here we are going to have the two variables, int a comma int b, and here, right, int a int b, and I'll just put a semicolon, right? So this is not the lambda, this is the interface, right? I'm going to use the lambda. During the lambda I don't have to specify the return type there. Okay, we'll see that one while defining the lambda. So let's create another class. Let's say, sorry, so let's say area uh, class. Okay, so area class, here main method. Okay, So now what we're going to do, we're going to use the lambda. Okay, so area interface. Okay, so let's create the reference of the area interface. Area interface, so AI equals to we cannot have like we cannot create the object of the interface directly, so I'm creating an object reference at the reference to the interface, and now that interface type of variable is going to get assigned to the lambda. If you have seen the very initial sessions of the functional programming, you might have known, right? So functional programming, the lambdas will be assigned to a variable. What kind of variable? The variable should be a type of the uh, single abstract method, like whatever the functional interface we are defining, that should be a type of that one, right? And now I'll say, okay, so a comma b, okay, so a comma b lambda, so lambda expression I'll say return, sorry, flower basis, so return a into b. Okay, so what I'm going to do here, so I'm saying I think I have to give something here. Okay, so I'm saying the interface area AI equals to the reference of the interface equals to a comma b, or I can give some other value. I think int a int b we have given here, right? So if it is causing the confusion, like it is same variable, I can say something else, xy, okay, or j and k. Okay, so j and k, return j into k, right? See, so this is also perfectly all right. Okay, so now I'm going to use this. So how am I going to call this lambda? The lambda is going to get called with the interface reference and the method defined inside the interface. So I'll say s out inside the system.out.println, I'm going to calculate the area. So I'm going to say ai dot, we have the area method. If you see, what is the method here? Area, right? So I'm saying area, and I have to pass two values here, so a comma b. So let's say 3 comma 7. Okay, so now if I'm going to run this one, run, so I'll get the multiplication of these two value, that is 21. See, so we got the value as the 21. Okay, so hope this is clear, right? So how exactly we are using the lambda function with respect to the functional interface. Okay, this is clear. If anyone is asking in the interview, you try to give this kind of example, like we have a interface, and in interface we declare a single abstract method, and then we have a class. In that class we are defining the object reference for that, like variable reference to that interface, and we are defining a lambda, and with the help of that interface reference, that is nothing but the AI here, we are calling that method that is declared in the functional interface, and we are passing the parameter if it takes any parameter, and it is going to uh, invoke the lambda, and it will do the operation defined in the lambda, and it is going to give the result. Okay, so that's how we will explain. This is most important concept, guys. Okay, so the next one, so can you explain the different parts of the lambda function? Okay, so what exactly lambda has? If you see, this is a lambda. What does it contains? Okay, what is the content of the lambda? So lambda basically has the three part. Okay, so first part is the, if you see, this is arguments, right? J comma k, then this is optional. If you don't want to take any argument or don't want to do any computation, you just want to simply print something, right? So you don't have to define this J comma k, just as open and close parenthesis is sufficient. Okay, so that is the first one, is the optional parameter, and then the lambda symbol. So this is nothing but the lambda symbol. Okay, and then the lambda symbol, after lambda symbol or the parameter, and then the lambda definition or the body. Okay, so here if you say, this is the lambda definition. Suppose here I'm returning, instead of returning I can say sop j into k. that also I can say, right? So the body, it might return something, or it doesn't want, it cannot also return anything. Okay, that is fine, it returns a body also. Okay, so three part we are clear. One is the optional parameter, lambda expression is the mandatory, and then the function body, lambda body. Okay, either it might have the return type, or doesn't have the return type, doesn't matter. Okay, so these are the three things we have in the lambda expression. Okay, and there are few other questions related to the streams and the optional class, which we are going to cover in the next session. Okay, so thank you everyone. If you guys are liking my videos, then please show your love by subscribing to my channel and sharing with your friends. Please do like to my videos, and then do subscribe. Okay, and if you have any questions, please feel free to put them in the comment section. Okay? So thank you. We'll see you in the next session with the Java 8 stream related questions and answers. Thank you.